Okay, now fundamental problem 614. So the question asks you to determine the horizontal and vertical components of fraction at pin C. So at pin C, you have the horizontal, right, and vertical component of at pin C. So you need to find what are them, Cx and Cy basically, right? So as you can see, this is a frame, right? This is not a, actually if you look at this, it looks like a truss, right? But again, that one, those are just the system. I mean, depending on how you load that, it will determine whether it is frame or truss. In this case, it's definitely not a truss, it is a frame. One of the obvious reason is because, you see this loads, 400 and excellent loads, 400 and 500 Newton loads applied at the member itself, right? For truss, you have to apply at the joints. It's okay. So in this case, it is a frame, right? And you have this 400 Newton, 500 Newton, okay, applied on member BC, and you have this member AB with this dimension, the dimensions of 0.9 meter and 1.2 meter, alright, and 1 meter, 1 meter each. So basically, the question asks you to find directions at joint C, horizontal and vertical, which means that you need to find what is Cx and what is Cy, right? Here, if you want to do long way, then you can do long way. But if you realize that this AB actually a two-force member, right? Then you don't need to draw the free body diagram for AB, and you don't find directions at this and this, right? So in this case, this AB is a two-force member. Okay, how do you know that? Because it is pin supported. At both ends, and there is no external load applied to it. So this is a two-force member, right? Okay, so if this is a two-force member, then you just have to draw the free body diagram for member BC. Okay, so this is member BC, right? The horizontal member, which is B and C, right? And then of course you have 400 Newton and 500 Newton load applied, right? And what else you have? Of course, the one here that you have here is Xy. But what happened at AB? Basically, if you don't know that this is a two-force member, you will say that okay, you have, because it's pin, you have dx and dy, isn't it? But because you know that this is a two-force member, basically you just have to. It will be simplified, right, to be just this, which is FAB. It's okay. Simply means for AB, basically you have this FAB along the member AB, alright? So this is FAB. Okay. What is the direction? The direction is 0.9, 1.2. Alright. So actually it is equivalent to 3, 4, and 5. Right? How do I do this? You need to check yourself. Okay. And this C, at point C, you have Cx, okay, and then you have Cy, right? Or Cx. How do I know Cx goes this way? It is because this FAB, I draw it going to the top right, isn't it? So top right, yeah, top right. So this Cx must oppose this x component of FAB, right? Cy, you have to assume, okay. All right, and then now we can solve this. What do we want to do first for this? See, if you do moment about point C, then you can find FAB directly, right? So that's the strategy now. Doing moment about point C equals to 0 will give you this one, right? FAB, the y component of it, the vertical component of it, times the total line, right? Total arm, sorry. 3, 1, 2, 3 meter. Okay, and then you turn it, it will be clockwise. Right, so FAB, the vertical component of it is 4/5, isn't it? FAB 4, okay, 4/5 times, okay, that's the y component of FAB, right? Times the distance, which is 3, 1, 1, 1, 3 meter, right? Minus 400. Okay, now why this minus? Because 400 Newton will do moment which is counterclockwise, isn't it? Okay, counterclockwise. So, okay, let me do this. Assuming clockwise direction as positive. So 400 times 2 minus 500 times 1, alright, equals to 0. So if you solve for FAB here, you can see from this one equation you can solve directly your FAB. So your FAB is 541.7, right? But this is not the answer. I mean, you don't need to find this FAB. It's just I mean FAB, you need this FAB just to find this CX because the question actually asks you, okay, you have to be focused. The question asks you to find what is CX, right? You got FAB, FAB, now you can find CX. Why? How to do that? You do f for x equals to 0, isn't it? So you have FAB, the x component of it is 3/5, isn't it? 3/5 minus Cx equals to 0. So your FAB is, now you know that it is 541.7. So your Cx equals to 325 Newton. Right? This is the horizontal component of a reaction at C. And then to find Cy, you can do moment or you can do Fy. It doesn't matter. So if you do summation of y equals 0, moment means that you do moment about point B, okay? Because you have done moment at point C and then you got FAB. Now if you do moment about point B, then you get Cy, right? So you do this, Fy equal to 0. So you have the y component of FAB, which is FAB is 541.7. Okay, the y component is 4/5, right? And then minus 400, the external load, minus 500, the external load, and plus Cy equals to 0, right? And then you get your Cy equals to 466.7 Newton. Okay, Cy equals to 466.7 Newton. Alright, so this Cx and Cx is your reaction, horizontal reaction at point C, while Cy is the vertical reaction at point C.